Alrighty. So today I'm going to be talking a little bit about predictive policing, as you may have guessed. And how I'm going to start out by doing that is talking a little bit about machine learning, and in particular machine learning when we're dealing with biased data. If you're one of the probably 10 to 15 people here who aren't one of the quant type of people, don't worry, I'm going to be talking about machine learning in general with pictures and no Greek letters and no equations. So please don't exit just yet. We're going to be okay. And for all of the all of the machine learning type people who are already here, we'll get through it quickly so we can get on to some of the more interesting stuff. So after I introduce machine learning a little bit and talk about that, I'm going to get into predictive policing, which is essentially predicting crime using machine learning. I'm going to present a case study that I've done using data from the city of Oakland, California. Okay, so what is machine learning? There are a lot of words on this screen, and if you are among the people who does machine learning or is adjacent to people who do machine learning, you may have heard some of these words. Maybe you've heard of random forest or reinforcement learning, or perhaps deep learning. That one's very popular these days, very trendy, yeah? And I'm going to stop reading these words off of this page because actually I don't really care about any of these things in particular. From my point of view and from the point of view today, all I really want you to think when you see these things are that these are just ways to learn patterns and structure in data, and in particular in the data that you give to the algorithms themselves, right? Which of these various terms you pick, and many of them have these really clever acronyms, so if you look into that's really fun. Well, which of those cool models you pick is going to define how you learn the patterns and what types of patterns you can learn. So in some cases, some of these things will let you learn lines that are straight. Some of these things will let you learn patterns that look like squiggles. Some of these things will let you learn patterns that look like stairs. But ultimately, all we're trying to do is doing the best job we can, learning the patterns that exist in the data that we give to the machine learning algorithm. And so I'm going to illustrate this with a really simple example. This is a simulated example that I made a little while ago because I was invited to talk at an accounting conference. And yeah, I was really excited. Accounting conference sounded like a hoot. I thought it was, basically a junket. I was like super pumped. No, I wasn't, but actually it turned out to be like one of the best conferences I've ever been to. So if you're a huge nerd and you're looking for something to do on a weekend or a long weekend or something, check out an accounting conference. It's actually like much better than I ever would have thought. And the topic of this accounting conference was fraud detection. And there were a lot of people there talking about, in particular, using machine learning to do fraud detection. And as I was sitting in the audience, I was thinking, man, I had a different talk planned. And then I was like, I should really sort of take this talk about predictive policing that I usually do and change the intro to be about fraud detection because we're really dealing with a lot of the same issues. And so here is my example for machine learning. Again, no equations, no Greek letters, no anything. So let's say that this is too bad. There's an X down here, by the way. You can't see that. Let's say that we have investigated all these companies in the last year, and we're really interested in predicting the fraudiness of a company. And yes, that's a technical term. I learned it at this conference. The fraudiness of a company based on something X that maybe we can measure or is correlated with something we can measure, right? So we're going to measure X, we're going to measure fraudiness for all of the companies that we actually investigated last year, and we're going to plot them. All right. And then we're going to apply machine learning to this, a really fancy machine learning algorithm that I call draw a line through the points. This is kernel smoother. It's actually legitimately something people do. But, for our purposes again today, we're just going to call this draw a line through the points. All right, and so this is our model. This is our machine learning model, right? How you would read this is that for, say, X is a value of 4, we would predict something like, where does this fall? Around here, maybe that the fraudiness of a company whose X value that we've measured is 4 is about, let's say, 2.5, 3, something like that in there, right? So this red line just corresponds to our prediction for any given value of X. And so if we were to use this model, use the red line, let's pick the parts of the red line that are the highest. Seems reasonable to where we should investigate in the future, right? So let's say the red line is really the highest right here. So for X values between 4 and 6, these are where we think the fraudiest companies, the companies with the highest fraudiness, are likely to live. And this is where we should direct our future audits, right? But what I was very cavalier about how I introduced this data. This data was the data that we just happened to investigate last year. This data we got because some people thought that these were the fraudy companies and these were the ones we should investigate. This isn't all the data. There are a lot more companies out there. Again, this is data I made up. But in this world that I've made up, all of the data looks like this. Okay, so all of the data is the gray points and the black points together. So this is what we call biased data when we're in statistics, or statistically biased data. And what we mean by that is that the points that we've collected in our data set, the black points are our training data, for those of us who want to use machine learning terminology here, so our training data, are systematically different than the population at large. The population at large being the set of all of the data points, right? You can see this in two ways. There's another way to think about this, and it's that some of the data points are more likely than others to appear in the data set that we're using to fit our machine learning model. So the data points with low x over here are actually much more likely to appear in the data set than the points over here. And you can't see this, unfortunately, because it got cut off a little bit. But actually, I was not telling you what x is, and x is CEO sneakiness. And that's how I made this data set, because for CEOs that are really sneaky, they're actually really likely to be very fraudy, except for if they are very fraudy, they're very good at not letting you know about it, right? They're very good at not getting on the radar of the auditors. And so we're not ever going to observe these people. Yes, there we go. So systematically different, statistically biased, that's all we mean. And there's sort of an unfortunate convergence of terminology here, because when we talk about bias colloquially, right, it brings up different ideas than when we talk about statistical bias. The case of predictive policing, which I'm going to get to, maybe those actually sort of dovetail, but in this case, I'm just talking about their bias in the sense that the data that we use to train our model, the black points, is systematically different than the data at large. So it tends to be a little bit smaller in X, and in particular for the large values of CEO sneakiness, we only observe the small points. All right, so if we'd had all of the data, our machine learning model, same algorithm for estimating, for drawing the line through the points, would have looked something like this. And then we correctly would have inferred that the fraudiest companies are the ones that fall over here. These were the really sneaky CEOs, and this is where we should really be directing our attention in the future. All right, so was this a huge failure of machine learning? Is all this hype about machine learning completely unfounded? What went wrong here? Let me go back here. This wasn't really a failure of machine learning, right? The algorithm did what we asked it to do. We asked it to draw a line through the points. We asked it to learn a pattern in the data, and it learned a pattern in the data that we gave it. It just didn't have the other information that we were missing, this huge swath of information over there, this huge swath of data over here. I think a lot of us have heard the saying, garbage in, garbage out, right? And that's sort of cliche at this point. This is what I like to think of as bias in, bias out. So we put in biased data, again, data, the black points that are systematically different than the data at large, and our machine learning returned that same bias. This is bias in the sense that the companies with a lot of sneakiness were observed to be too low, and our machine learning model returned that same bias in its predictions. All right, this doesn't just happen here. This is just, again, a very silly example that I've created to illustrate this point. So this makes you have, at this point, what we have to really think about is, what is your data measuring? So unless you have a complete census of all of the companies, so in this case that'd be both the black and the gray points, or a random sample, which there are a lot of ways to generate those, but a random sample without further definition there. When you collect data about something, say X, without having either of those things true, X is not actually a measurement of X. The data you have is not actually a measurement of X. It's a measurement of some complex interaction between X and your ability to observe X, right? So in this case, this model here, this first model, we're talking about some complex interaction between fraudiness and our ability to observe the companies, right? We're not actually learning something about X is not actually measuring fraudiness itself. And when we make predictions on the basis of that model, we're not really making predictions about X, or making predictions about something like our ability to observe X in the future, or some complex combination of the existence of X in the future and our ability to observe it in the future. It's a little bit heady, but I think with the example, maybe we can all get there. All right, so in the context of predictive policing, what does this all mean? I just said what we really need to think about very carefully, spinning here, is whether we have a random sample and what our data is actually measuring, right? So the question then, when we are applying machine learning to police records, which is what predictive policing is are police records a representative sample of crime? I put the answer up there already because I didn't want anyone to look bad and sit here like, are they? I don't know. No, the answer is no. They're not. They're not actually a representative sample of all crime. What makes you think that? I will expand a little bit because that's kind of just to put it up there like that. The first thing is decades and maybe centuries of criminological research lead me to believe that police records of crime are not a representative sample of all crime. So again, representative meaning that each crime that occurs has the same chances of ending up in the police records as any other crime. The first paper I saw mention this was from something, I think it was like 1896 in the Royal Statistical Society journal. Pretty cool. They're talking about how arrest records were not very good measures of crime. They are biased. You can actually look into this yourself. There's a public data set called the NCVS, the National Crime Victimization Survey, and you can look at reporting rates by different demographic types, and you'll find very different reporting rates. So for example, some types of crimes are very much more likely to be reported than others, and certain types of people who are victimized are much more likely to report a crime than other types of people. And so because a lot of data ends up in the police records because it was reported, this is another source of bias, right? This isn't necessarily because the police are biased, to use the colloquial term. This is because people are reporting at different rates. People who trust the police perhaps are reporting at a higher rate. People who don't trust the police are reporting at a much lower rate. Just using some somewhat common sense, you could also think about this, that crimes that are committed in areas that are highly patrolled by police are more likely to be discovered by the police than ones that are committed in less patrolled areas. I think that's relatively obvious. If you're looking for something, you're going to find it where you're looking, as opposed to where you're not looking, in general. And here's a very specific fact here. So while white and black populations use marijuana at similar rates, blacks are arrested for marijuana possession at a rate that is several times that of whites. And I gave you a, well, unfortunately you can't see the whole thing, but if you want the link later, I could give it to you also, a citation for that, because that's a pretty bold claim, but it's true. And so let's think about, again, go back to our previous example and think about predictive policing. Again, applying machine learning to police records, which are biased. In the context of what we just learned about X, not really measuring X, measuring some complex interaction between things. So what they'll say, or what I'll even say, is predictive policing uses police records to learn patterns in the occurrence of crime. Well, this is only true if the police records are a representative sample of the occurrence of crime. So actually what it's doing is learning patterns in the occurrence of police records, right? Learning patterns in the police records, learning patterns in those black points. So using these patterns, the computer then predicts the most likely locations for future crimes. So again, what we're talking about with predictions on biased data, actually what this will be predicting is where crimes will be detected in the future, right? Not exactly where crimes will be in the future, but where we'll be able to observe crimes in the future. So then, based on those predictions, additional police will be dispatched to the locations with the highest predicted rate of crime, thus preventing crime that would have occurred or catching criminals in the act. This is, again, the whole goal of predictive policing. And to this I say, what happens if you actually find crime in the locations where you're sent that you wouldn't find anyway? And that's something we're going to investigate in a second. All right, so now on to the case study of Oakland, California. This shows all of the drug crimes in Oakland, California in 2010. And I got this data from Open Oakland, which is a source for basically government data from the city of Oakland. And so it's basically crime reports. Reports is sort of, it's not only things that were reported to police, but when police took a report. So it could be something they found themselves. It could be something that was reported to them. It could be because they made an arrest for something that they happened upon. So all the crime that ends up in the police database. And we filtered this down to just drug crime reports in Oakland in 2010. One quirk to notice here is that Piedmont is not really showing something right here. It's sort of left out. And that's because Piedmont is sort of this gated city with Oakland. Not really gated, but it's a separate administrative region. And so because it's a separate administrative region, we didn't even want to mess with that because there are all sorts of different data collection going on. They might not even have the police data from in this data set here. So we're ignoring this section for our purposes today. Okay, that's outside. That is, what is it, Andorra, one of those countries that's completely tucked in the middle. All right, and so what we see here, this is a heat map. Each square, each bin, shows how many of the drug crimes. This says arrests, it's actually reports. That's a mislabel. We're in each location in Oakland. So what we see here, this is where most of the drug crimes exist in the police records. And there are also some along here, and I hope that the difference in color is good enough for you guys to see all in the back, but most of the crimes are found here in West Oakland. And there are several, it's a little bit lighter here, but it's definitely pink. And there's a non-negligible number that are found here around Fruitvale and right along International Boulevard. Up here, basically no crimes are found. Pretty much none. And so there's a specific reason that I picked drug crimes to look at. And that reason is because I think I can come up with a decent estimate of where drug crimes are being committed. Because people other than the police collect information on who's using drugs. And those people are public health officials. They do surveys on who's using drugs, and I think that people are probably more likely to report drug use to public health officials than they are to police, given that the public health people are trying to help them, or at least just gather information. The police are trying to arrest them. And so this is probably a more reliable source of information on drug use. The other evidence I have that it's a more, a less biased look at drug use is that the Department of Justice Statistics, who does keep the police data, also uses this source of data that I've used, the public health data, to make comparisons as a sort of ground truth for who's using drugs. So it's not just me that thinks this is a better comparison. So what I did was I used some very highly detailed census data and combined it with the survey on who's using drugs based on demographics, and estimated this map of where I think drug use is taking place in the city of Oakland. These maps look pretty different, I think. Basically what you see is police are observing or recording drug crimes here and here, basically one location a little bit here, but people are doing drugs everywhere in Oakland. And I've actually checked, I don't live in Oakland, I live in the Bay Area now, but I've talked to people who do live in Oakland, and this has been anecdotally verified. Yeah, people are doing drugs everywhere in Oakland, okay? Like, I'm saying this is an estimate, it is an estimate, but like, come on, people are doing drugs everywhere in Oakland. And most of the variation here, so this looks somewhat similar to this map, right? But actually a lot of what's going on is these are just higher density areas. Oops. Most of the differences in these areas have more to do with population density. So if we look at the rate of drug use across space, it looks more like this, where it's really pretty uniform because everybody's using drugs in Oakland, again. But what we see are this sort of big difference, right? Again, we see people are doing drugs everywhere in Oakland, but police are recording drug crimes in these very few places. And that's something I'd like us all to remember before we get to the next stage. I want this image here to be burned into your mind, and I would like this image here to also be burned into your mind, so I'll just let you do that for a second. All right. By the way, this is something, so this is what we call, again, to go back to the terminology I was talking about earlier, biased data, right? The crimes that occur here and along here are much more likely to end up in the police database than the ones that say occur over here, or even up here, right? And this is Berkeley, so we know there's some drugs going on up there. All right. So this sort of begs the question, who's living in these places that are vastly overrepresented in the data, that I would, dare I say, over-policed those two regions? Who are the residents of those areas? So I've circled these two areas where really all the drug crimes are found in the police database and matched it up to the best of my ability with one of these really cool dot maps. So each resident of Oakland is represented by a dot. I didn't make this map. This is the citation for who did make the map, and it's a really cool map, and you should totally go look at it. So over here, you can see that each white resident of Oakland is indicated with a blue dot. Black people are indicated with one green dot, Asian with red, and Hispanic with this sort of yellowish, orangish, depending on how you see that color. And I've tried to match up this here and this line here on these two maps the best I could. And so we can see the places that I would say are that are overrepresented in the police data are primarily occupied by African American communities and Hispanic communities. That's what this would indicate, right? Okay, so what happens then if we apply predictive policing, a predictive policing algorithm, to this data? We have this data from 2010. What happens if we take that data, apply a predictive policing algorithm to try to see where it would dispatch police for every day in 2011? That was my goal. I just wanted to see, where is it going to send police? Where is it going to tell police to go? So Predpol, which is a company, I keep doing that, I'm sorry, a company that, yep, that's what happens when you step on your cord. Okay. They're a company they're a vendor of predictive policing software. They actually charge quite a bit of money for this. They published one version of their algorithm in a peer-reviewed journal last year. I don't think it's their full algorithm, but they did actually deploy this algorithm in 3 cities throughout the world. Actually, one was LA, one was Kent in the UK, and I've forgotten the third at the moment. But this is the algorithm they're actually using to dispatch police, at least in their field trials. So this is not something that they just published for the sake of publishing. They're actually using this. So I reproduced the algorithm that they published because, hey, why not? And I wanted to see what would happen. Applied it to the data from the city of Oakland. I'm going to make predictions for every single day of 2011 on the basis of the data from 2010. And before I start the movie, because it's going to catch your attention. I know you're all going to stop listening to me when the movie comes on. What you're going to see are red. Each bin is going to light, some bins are going to light up as red, right? And that's going to be where the algorithm predicted the highest rate of crime would be and where police would be sent if we had done this for each day in 2011. There'll be black dots, and that's where crimes actually were found in that time period. All right, let's see how this goes. You gonna run? Okay, so this is where the algorithm is sending the police. Does this look familiar? I asked you to burn a map into your brain a few minutes ago. This looks a heck of a lot like the map that I said was biased, right? So if the predictive policing software were doing something to sort of ameliorate the bias or the over-policing the data, what we'd expect to see, right, would be red splotches pretty much everywhere. They would actually be going up into these areas where the white people live because they're probably drugs too. But actually what this is doing is reinforcing the bias that already exists in the data, right? We only really were observing drug crimes there, in these right along these two places, and now we're only looking in those places because that's where the algorithm is sending the police back to. I think there's this sort of common misconception that machine learning is going to solve the problem of bias in policing or bias in the criminal justice system, because in this algorithm, the reason people think that is this doesn't actually take race into account, right? Like, you don't know what the algorithm is. I have several slides at the end if you really want to get into the weeds. You probably don't. But it doesn't actually take race or anything like that into account. It just uses the past history of where the drug crimes were. But because those were in these communities of color, and I'm not showing income, but in lower income communities as well, it's sort of reinforcing those biases that already existed. So another way to look at this is what percentage of the population is receiving targeted policing in 2011 under this scheme, right? So we can see over here, that black people are about twice as likely as white people to reside in a location that receives predictive policing if we were to use this model in 2011. And this is specifically predictive policing geared towards finding drug crimes. If you were to estimate the rate at which people use drugs in Oakland based on the demographic profile of Oakland and that public health data I was talking about earlier, you'd find that the rates are very similar. And so it's not only that black people or black populations and other minority populations are receiving predictive policing at a higher rate relative to white people. That's not the only problem. It's high relative to their rate of drug use, right? This is disparate treatment. So then, what I wanted to know is, what if police find a little bit more crime than they would have anyway when they spend time in those targeted locations? So in the first movie I showed you, the police go to the locations and they just do what they would have done anyway, right? There's no additional, I was assuming that they don't find anything else. I was just using the historical data unchanged just to see what would happen if we'd taken that historical data exactly as it was and made these predictions. So what if, when the police show up at a location, they actually find a little bit more crime than they would have found anyway? We can actually investigate that by simulation. In this case, we're moving away from the raw police data and we're sort of going into a thought exercise situation. We can simulate it, right? So we'll look at where they would have been sent, and then we'll add a teeny bit of crime, a 20% extra. Most of the times that's nothing extra. Most of the time it's nothing, because most of the time they don't actually find anything there. And just see what would happen with the algorithm if we find just a small bit extra crime every time we go to those locations that are targeted by the predictive policing algorithm. So you're going to see a very similar movie. I'm not going to explain what you're going to see again, because it should look very similar. Got to start it. Is it going? There we go. It's actually hard to see the difference between this movie, but you can see that I'm simulating a few extra crimes because the black dots appear inside those bins a little bit more often. So slightly more often we're finding crimes in those bins because we're looking there. And again, this is a thought experiment. This is a what-if scenario that I'm simulating. What if we did? And then as they find more crimes in those locations, that data is fed back into the algorithm to make predictions for the next day. So I find on January 1st, I find a little bit of extra crime in this location because I was sent there to look for it. Then that data makes its way back into my training data to make my prediction for January 2nd. You'll notice these things actually aren't moving nearly as much. It's hard to see because you'd have to have them side by side. But trust me when I tell you, these things aren't moving very much anymore. Look at that. Is this plot over here, which shows you the predicted odds of crime in targeted locations. So I have to unpack this a little bit. So this is from the original scenario. And this just says, for across the year that I was simulating, the algorithm told us that they thought there was about 20 times more crime in the red squares that it was predicting than in the other squares on average. And this remained, I mean, there was a little bit of a drift, but it remained relatively constant because we weren't adding extra crimes when we went to those locations. When we start adding just a teeny bit extra crime every time we go to those locations where we're meant to be looking, this actually amplifies the bias that exists there. So when we started out in this, so this black line represents a simulation here where we're adding a little bit of crime each time we go to one of these locations that are targeted. And at the beginning, we start the same, right? We think there's about, the algorithm is telling us there's about 20 times more crime in the locations where I'm sending you. By the end of the year, it's now telling us there's about, 65 times more crime in the locations where I'm sending you. And this is a feedback loop, right? You're going to these locations, first because you historically, for whatever reasons, thought there was crime there. But now you're going there because the algorithm's telling you to go there. When you go there, you find crime, you feed that back into the algorithm, and it tells you to go back there again. So it sort of creates this vicious cycle. We're talking about drug crimes, right? You can always find more drug crimes. And so this is exactly what would happen. It actually has the potential not only to reinforce bias, like we saw in the first example, where we just used the raw data completely as it was. If they actually find a little bit more crime, this can actually amplify the bias that exists in that data. So if you were then to use this data set to make inferences about where crime was, right, by the end of the year, you'd be saying, man, these locations really have a lot more crime. They have 65 times more crime than the unpoliced locations, right? Whereas at the beginning, before we implemented this program, we would have thought they'd only had maybe 20 times more crime. So I will sort of start winding down here. The things I'd really like for you guys to take away from this is that crime is everywhere, and police don't know about all of it. Hopefully that's not too hard of a sell here. And what they do know is not really a representative sample, and there are a lot of reasons that that's true, and I think there are even people in this audience who could talk about why that's true, even better than I can. Bias data in general in machine learning or any sort of thing, unless you're explicitly correcting for it, will result in biased predictions, predictive policing included. And actually, if increased targeted policing leads to an increase in the number of arrests, like we saw in the second simulated scenario, targeted policing will magnify or amplify or worsen the pre-existing bias. And because of the biases that exist in the police data historically, at least related to drug crimes, predictive policing will disproportionately affect historically over-policed communities, and in this example, that was minority communities. And although I didn't show it, it was also low-income communities. And before I close, I sort of want to preempt the question that I always get next, which is how is this any different than what police are doing anyway? Okay, maybe the algorithm's doing it, but what they're doing is they're going back to places they found crime before anyway. And I'd say there's two differences. When it's an algorithm doing it, it's going to be a lot more targeted. You're going to hit the same spots over and over and over again. If you think of my first example with the black dots, the computer draws the line. When you send the same exact algorithm to draw a line through those points, you're going to get the same exact line every time, and it's going to tell you, right, it's right between 4 and 6. This is the spot that's the highest. If I asked each of us to draw a line, or even the same person to draw several lines through that data, it'd be slightly different every time. So you'd sort of spread out the effect. You wouldn't have such targeted, such concentrated policing if you had humans do this. And you can actually see this in real data when they did this in the field experiments. The thing that I worry a lot about is that this takes away some of the accountability. So previously, if humans are making this decision, you can actually go ask them, you know, hey, why are you sending people to West Oakland and International Boulevard all the time looking for drug crimes? Why is that? When you're paying a lot of money for software that seems really high-tech and really fancy and in some ways inscrutable to the people who've purchased it, I mean, now what they get to say is, oh, well, this really fancy, really expensive software that we've, you know, spent a large portion of our budget on, that's what told me to go there. It can't be wrong, you know? People are making great strides in Silicon Valley. People are making tons of money using machine learning, using deep learning. Perhaps we can't get left behind. And so that's the thing I actually worry about most, is how this shifts accountability from the people who are making decisions to this software. And so that concludes. Thank you very much. I have several more slides you guys aren't going to see unless you ask me very specific questions later, and I don't think you will. But thanks. And thank you to Sorrel for inviting me, and to the panel people who come up here next. Oh, and sorry, one more detail. What I showed you is actually mostly the results from a very, very short paper I recently published with my colleague William Isaac, whose name was on the first slide also. It's at this URL, or you can just Google to predict and serve, which is probably the easier way to come by that location on the internet. So, should you be interested? Thank you.
So thank you. And actually, your closing question or sort of comment was a nice segue into where we're heading with this. So I want to invite up Rebecca Wexler, Have
Did
a
we
seat.
can move the
You
chairs?
should also grab a seat. I'll move
We need
the
to
chair.
move. I can move the chairs.
Yeah,
We are moving the chairs,
I
right?
wanted to, oh, okay, you're gonna move yourself.
Oh, I thought we were supposed to move the chairs.
Good.
I just do what I'm
Let's
told.
do that. We can have a little rearrangement. I got it. Hold on.
We're moving the table. Okay.
It's all very fancy. Have a seat.
Okay.
Sure. Okay, so I wanted to sort of give the two of these folks a little bit of a chance to chat sort of in a panel style thing, perhaps giving Rebecca the chance of, say, the first question. So maybe you could introduce yourself and say a little bit about what you've been thinking about, and what you found interesting in this, and then we can sort of start the discussion up here and then move it out towards questions in a little bit.
So my role, I'm Rebecca Wexler. My role here at Data and Society and intersects some with my work with the Legal Aid Society. Is focusing on criminal defendants' access to data. And so what struck me in particular about Kristian's paper is that Predpol had released this algorithm and also the training data that you were able to obtain.
So Predpol did not release that data. That comes from the city of Oakland. They have one of these open data initiatives. I actually emailed the authors of the paper, who are the owners of Predpol, several times, and had several incognito people email them several times. Like people who are not affiliated with the human rights group, for example, just totally random people. They never responded to any of us. So
you don't know the training data that went into the Predpol algorithm, but
right.
you were able to find alternate data so that you could do
yes. But they did not actually give me the data. I just wanted to be clear on that because it is helpful because we don't know exactly what happened in their data because they won't share it, even though that they're supposed to based on the journal they published.
So even though Predpol is coming out sort of on top with the transparency here, having been one of the few vendors who've released their algorithm, is still not fully transparent. They could be more transparent as well.
Yes,
is what you're saying.
I agree. And in fact, I think they should. Usually when you publish in peer-reviewed journals, there's some expectation, and Sorrel can speak to this, that the research be reproducible. And in this case, reproducible would mean there's code available and you could run that code on the data, and then you can get the same results. You can get the same hotspot map that they'd created in their paper. In this case, they did publish the algorithm in words, but not the code. So that was quite a bit of work to re-implement that, and they did not give us the data. So it's only partially
Would you be able to go
reproducible.
into actually more detail about the work that it took to re-implement because they didn't provide the code? So some of the pushback that I'm often getting when I'm arguing for code disclosure is, well, we don't need that because we can do black box testing, and so if we get your data, we can just evaluate it. Or you could potentially have taken the open data from Oakland and just created a new algorithm and seen whether how it compared to where the police ended up going. So what about what do you actually need to do best practices in your audit?
Well, in this case, what really would have been good if they'd given us the code itself. So in that case, right, that would be more like black box testing, like maybe not giving us the code, but giving us an API to hook up into their code so we could push data through their code and get an answer, right? And maybe we don't know all the inner workings of the code, but we can at least ask the code a question. Where will you send police and get an answer back, right? Even without having access to the algorithm itself. Okay. So that's sort of black box testing that people usually talk about. This is sort of the opposite, where they said this is the algorithm, but you can't have the code, which in some ways is worse, I think, because it took an awful lot of time for me to put this back together, especially given there were definitely some typos in the algorithm. There was definitely a lot of going back through the previous literature in this area and trying to sort of reconstruct what they meant when they said certain things. And so it wasn't as clear-cut as one would like. It ended up being, a much, much larger task to actually do this sort of reproduction or re-implementation than if they had given me some sort of black box API. And I think I would have actually preferred the black box version, at least, from the point of view of doing the work. Would have been a lot less. From the point of view of intellectual curiosity, it was actually pretty fun to code it up. So there's that.
So and then just to wrap up, and because I know we want to open up to others, but I guess the general question that I'd like to ask is, how common is it to have a vendor release any information, and what are the pros and cons? I mean, both sides, and Sorrel as well. I'd love to hear your thoughts about having proprietary barriers to access at all in criminal justice technologies.
So first, the question was, how common is it?
Yeah.
I think it's pretty uncommon, at least in my experience. Once I saw this algorithm, go ahead.
So one of the things that I wanted to sort of point out about Kristian's work is that the idea that predictive policing algorithms might be creating a feedback loop has been around in these circles now for a few years and has sort of been taken as a given. But this is the first work that actually manages to show that in data, right? Which makes it really significant. At least it's the first work that I know of that does this. And I would say that part of the reason why, even though this has been sort of common lore now for a while, that we haven't actually gotten to see the sort of data-driven proof of that is because it's so hard.
Yeah. Hard to get access to the algorithms to do the independent audit.
Hard to get access to the algorithms, hard to get access to the data. Hard to have any sort of justified simulation of what's actually happening here.
Yeah. This is the only case, to my knowledge, where they've actually published the algorithm so that you could, with enough effort, reproduce it. And getting the data, I mean, you said, what are the downsides? In this case where it's just crime locations, they could probably jitter them, so there'd be privacy. I think there are some privacy issues with creating a fully reproducible setup like this. Like if they had given me the data, I would hope that they would have done something to make it a little bit more anonymous. So if they had, who was arrested where, that probably should be omitted. But I think there are, just in terms of downsides to transparency, we're talking about somewhat sensitive information in terms of, people's criminal histories. And so making that just widely available on the internet in very easily digestible form is maybe less good.
And Sorel, did you have a thought as well about some downsides for transparency there in terms of just incentivizing companies to?
Yeah, so I mean, I think my caveat that I always want to give in terms of thinking about transparency is that I think that often when we're thinking about code, our first guess at what transparency should look like is that we should just open source the code, and then somehow that'll make everything okay. But in fact, while it can be useful for a technologist to have access to the code, if you want to actually understand what the code is doing, that requires a lot more than just having access to look at it, right? If you imagine that you had, if you imagine that you took code and you printed it out and you had like boxes and boxes and boxes of printouts and you were supposed to somehow synthesize all of that, right, and figure out how what you sort of fed into the algorithm caused some output, that's a hard job to do, right? And it might even be that there's a whole team of engineers working on this and that, no one of them even fully understands the entire system of code, right? And so I think that's one of the things that I worry a lot about with transparency. I think that sometimes sort of the word transparency can make people think, well, I'll just make it open and that'll satisfy that. But I think that there should be more of a call towards sort of explainability, right? Explain to me why the algorithm made this decision.
And so just to add a possible legal perspective to the tech perspective here, I would actually suggest not the confidentiality issues, but the trade secrets and proprietary issues are relatively new in the criminal justice space. They're not completely new, but they're relatively new. And if you look back to sort of the beginning of the growth of something called a trade secrets privilege and evidence law, this really didn't exist before the mid-20th century. There were protections for trade secrets in civil cases, and they weren't applied to criminal cases. And as this technology comes into the criminal justice system, it's bringing trade secrets and proprietary claims with it. So I do think it's actually an open question how we should handle those from the legal perspective. I'm done.
So.
Care about that one.
Open it up.
No, that was great.
For questions. I will run the microphone down. Nope, because now I'm over here.
All right. I'm just wondering if Predpol has responded to your study.
Not directly to me. I wish they had responded a long time ago when I was trying to get their code, but they won't respond then, and they haven't responded directly to me now. They responded through some reporters who have asked for comment. And what they said was that they thought we were using slightly different data than what they normally use, which is, I think, willfully missing the point, the bias in, bias out point. I mean, whether we're using the exact same data or slightly different data, all of the data is going to have very similar issues in terms of bias. And so I think it was sort of a way to, brush it off as irrelevant to what they're doing. But they're not stupid. They're bright people, and I think they understand the critique very clearly, and that was just deflecting. So that's the only response I've gotten. No. Just to be clear, no, they did not say that.
Kristian, I had a question about thinking about essentially the interface between the police and the system. So just because it makes certain predictions, we don't necessarily know that they're going to act on those predictions. So do you have a sense of whether or not there's a way with the data that's available? You know, so for example, if you know that, oh, PredPol was implemented in 2012, and we've got data pre and post to kind of get a sense of how much of a kind of bias, you know, they could be already biased in their own thinking about where they go.
Whether there's this feedback loop, whether we could find evidence in real data of the feedback loop as opposed to
I'm just curious, about that
yeah, so actually when I started this project, that was the exact first place I went with this. I think that would be even more compelling evidence that this is creating that feedback loop. Unfortunately, although some cities will tell you that they're using PredPol, you don't really know exactly the day when they start using it, and you don't usually have crime data that's granular enough to be able to see a change point. And you would need a lot of different cities, because it's so noisy, the crime data anyway, to be able to detect that there's this sort of change point that happens when they start using it. And my guess, this is completely conjecture, but my guess is if they start using it, they probably sort of like phase in rather than just on day one, everybody starts going there. And so I assume it would be really hard to find that way. I think you would need data, sort of police activity logs or something. And while a lot of cities are being really great about transparency in terms of this sort of crime data, I don't think police departments are going to start anytime soon giving us like their strategic maps or something like that. I just don't think that's going to happen. But I think that would be actually the most compelling version of what I've shown, and I think that's a great idea should you ever find the data to be able to do that.
Hi, I didn't quite catch how you said you created the unbiased drug user data of Oakland. I know you said you did census demographic data, but could you talk a little bit about how the real map was created?
So there are two maps. So the drug crime reports, that's just the raw data that comes from the police, the Oakland police. Right. The other one, it's a little bit complicated, but I used high-resolution census data. So this is something I worked on when I worked at Virginia Tech as a research professor for a couple years. And you do something called making a synthetic population. So you take as high-resolution census data as you can. You make one individual for every resident of a city. And you make the individuals in such a way that as you drill down to the smallest level possible, like so in the using census data, this would be block, which is very small. It's literally like a block if you're in a city, so that the demographics at that level match the demographics of the city. So if you were to take all the people that you say live in this little area in Oakland and count up their demographics, that would match exactly with what the census says that the demographics of this teeny tiny little spot should be. And there's a lot of sort of tricks and magic that go into making this work well, and it would take probably a whole nother talk to describe exactly how that happens. But the end result is that for every person in Oakland, we have a synthetic representation of that person. And we don't know everything about them, right? We just know the basic demographics. But if you aggregate at pretty much any level of resolution that's greater than a block, which is again pretty small, you'll find that the demographics of the people in your synthetic population are the same as the demographics in the census data. And so then given each of those individuals, I fit a model to, then I fit a model to the public health data. So I said, okay, given these demographic characteristics, what is the probability that you're an illicit drug user? And then because I have all those demographic characteristics for each individual in Oakland, which again are synthetic individuals, or estimated individuals, I can assign a probability to each of those that they use drugs. So based on their age, I think in 5-year bins, their race, their income, the number of family members in their home, their census reported race, things like that. And so while it's not perfect, I think it's a reasonable representation. It comes from SAMHSA, the Substance Abuse and Mental Health Survey, something with an A at the end.
What was the process for reconstructing the algorithm from the journal article, and how can you be totally confident that that matches what was used in the field?
I can't be totally confident that's what matches in the field, because they won't. If I could be confident if they would release their code, and then we could test, plug in the same data, their code and my code, and see that it returns the same thing. I'm confident that it at least returns something very close, because I went back to basically first principles from their description of their model, rederived everything from the ground up, and ended up with an algorithm that was very close to what they said they did. And it wasn't exactly the same because there were clearly some typos. And without going too much into the details, they're using an EM algorithm where you have to update the parameters iteratively, and there were some parameters in their algorithm they reported they used that never got updated. And so you know something's missing in that case, right? They're saying they're updating X then Y, X and Y, X and Y, but they just never told you how to update X. So obviously something is missing in that case. And so I had to go back from like first principles, rederive the whole thing. And when I did that, what came out the other end was something that looked almost exactly like what they said they did, minus the typos. when I tried to code up exactly what they said they did, the thing didn't converge. It gave nonsense. And so and when I coded this one up, I was like a good little programmer. I did some test cases. I said, okay, what if every bin has the same number of crimes at the exact same time? What will happen? Okay, well, it gives us the same prediction for every bin. What if this one has many more than this? And did all sorts of tests, reality checks, sort of to make sure that it gave me something reasonable. And so, to speak to your point, yeah, there's really no way to know for sure that it's exactly what they did, but I would bet a lot that it's very, very, very close.
So presumably the police department's involved in this in using these predictable algorithms, or using them to sort of like save resources and do this in a more targeted fashion. So they want some way to monitor fewer places than they had already been going. Is there a way to sort of fix or adjust or correct for this bias? Like, can you use the outside data that you were using to sort of correct or target people to a more representative sample of places, or is there any way to fix it, or do you just need to like stop using these algorithms
I mean,
entirely?
my preference would be just to stop using them entirely. And my preference, I mean, not to get too political, would be to sort of take a more expansive view of the role of policing, and rather than trying to like really stick it to certain people and predict things like this, which, to be fair, Predpol does say they do not predict drug crimes, but there was an NIJ call out for competition where they are doing crime prediction, daily crime prediction just like this, and one of the categories was drug prediction. So people are actually doing exactly what I just did here, maybe with different algorithms, but which algorithm you use doesn't really make a difference. It's all going to have the same problems with this feedback loop unless you do the correction. If you want to do these daily predictions, I think it would be really hard to do the sort of correction that I did. You could do some sort of reweighting scheme, like the rate at which you think crimes are reported, or do some sort of estimating sampling weights, essentially, so estimating the probability with which you think each crime does appear in the data. So if you find a crime in a location where you're very likely to find crimes, sort of downweight that. And if you find one in a location where you think you're very unlikely to find the ones that happen there, you'd upweight that. Now we're basically getting into survey statistics and reweighting, and this is a whole field that people have spent, a century thinking about or something. So there are ways to do it, but I think those weights would need to be changing dynamically also. And I don't really think there's a reasonable way to get those weights, to estimate those weights dynamically at the rate you would need to apply something like this on like a daily or even monthly basis. So you could probably make it slightly less biased, but I think we're sort of barking up the wrong tree here.
So thank you for your presentation and for the work demonstrating the pernicious feedback loops.
Okay.
I'm curious about ways to still do this predictive policing. I think you kind of answered that. You didn't think that was a great idea, but still use the algorithms, but undermine get into more virtuous feedback loops.
Right.
And so one idea would be, instead of sending police there to arrest people, you send resources there to help people who are addicted to illicit drugs.
Right. I think that's a much better idea.
Well, and it seems to unwind your pernicious loop and give you a virtuous one. And the other question is.
Well, can I respond to that one
yes,
first?
Yes.
Okay. So, one, I agree. And this is just sort of a philosophical stance, I guess, that I don't really think that we should be targeting people for drug use so heavily. And I think the right approach is, sending sort of more resources and maybe social workers or something like that to help them. But the converse of what you're saying, right, sort of the inverse, is that you could get stuck in this pernicious loop where you keep sending resources back to the same places, and because you're only finding more of these drug users in those same places, you're completely missing other places that require the resources. So it's that same feedback loop, but in reverse. So now, rather than penalizing concentrating the penalization, you're concentrating the support. Yeah, and so I think there's some of the same issues, but overall, I like that plan many times better.
So if you have better data, do you avoid the feedback loop, or do you think the feedback loop is going to happen regardless of if you had non-biased data?
If you had completely unbiased data, but you had the scenario where when you go to the locations that are predicted to have the highest rate, you find a little bit more than you would have found anyway, you'll create the feedback loop regardless. You'll actually create biased data even if you start from unbiased data. And so, yeah, that's a really good question or observation. I don't think that was actually a question. I think that was an observation, but yeah.
Hi. So first off, I love your Twitter handle.
Oh, thank you.
I was curious about whether you ran any experiments on the rate of bias amplification as you changed. So we talked about what happens when the crime rate increases by 20%, but were there any experiments that you ran when you looked at other different rates, or what happens if there are shocks to the system, like a certain region has a sudden spike in the crime rate, and how does that amplify bias, and how does that amplified bias then decay?
Yes, that's a great question. I fiddled a little bit with the rate because, to be completely honest, I pulled 20% out of anything you can pull 20% out of, say, a hat. And so there was some, fiddling with that to see if it needed to be 500% or 20%. But it just goes more slowly. If you tamper down that 20% maybe to 10%, then it'll just increase more slowly. If you make the 20% 500%, those lines they'll diverge much more quickly. In terms of shocks, I didn't look into that at all, but maybe that's something that one could do in the future. And we're currently in the process of doing a very detailed code. I think what do the programmers call it? A refactoring to make sure it's all like super readable for everybody who wants to use and like super well documented. It's actually the exact same code. We're just making it prettier and making it more readable for everybody. And I think we're going to have that out pretty soon, so that if you wanted to do something like that, you could do it.
Did you have a question?
I appreciate the talk really a lot. I was just wondering if you had any collaborations with communities that are actually experiencing this right now, and if you plan on to in the future, or what that looks like for you.
Yeah, that is another great question. And I'll come back to it, but I've been talking to some reporters about this type of work, right? And the first thing they always want to know is what are the stories? What's sort of like, what's going to be like your opening, right? The sort of heart-wrenching story of somebody who is affected by predictive policing. And I'm often asked, do I have any personal stories with this? And I'm like, well, I live in Los Altos. No, I actually don't. No, I haven't been targeted by predictive policing. And I think that's really what's lacking in terms of getting people really mobilized around this, is having those very specific, heart-wrenching stories about, I was affected by predictive policing. But the hard part about this sort of location-based predictive policing, where officers are sent to a location, is it's hard to say that you were found there because they were sent there relative to, something else like these heat lists where they actually target individuals. And so someone might end up being arrested or being busted for something, right? But I don't think they're actually going to know that it was because of predictive policing. And so I think that's something that's really lacking. And I think that's something where journalists or, human rights researchers or something like that, not my type of human rights researchers, I do this, but people who are actually on the ground and doing the real important work could really contribute to moving this forward. Sorry, what was your question again? I sort of went off topic, but because that's something important that I really wanted to say.
I was just wondering if you had any collaborations with communities.
So we sort of started down that path. When we first conceived this project, what we wanted to do was run a survey in Oakland and try to actually get good pictures of what crime looked like and compare that, or what victimization looked like at a very high resolution, and compare that to what the police records looked like to come up with a pretty robust example or demonstration of the bias in police records. And surveys are really expensive. Really, really expensive. And so we haven't done that yet, but we sort of started talking to some community groups in the process of sort of feeling out whether we were going to go that direction. But then when we decided that we were going to do more of this sort of virtual experimentation and sort of virtual demonstration, we haven't pursued that much further. But I do think that's another important aspect of this type of work. So I would like to in the future.
Hi, so first off, thank you very much for the talk. I'm curious if you've done any work, kind of looked into how police deployment, kind of prior to predpol, what police departments are doing, and how different kind of predpol actually is from what's happening before. And I think you laid out why this is different and why this kind of accelerates these phenomenon. But I was just curious about that.
No, I think again this sort of speaks to the point of the man behind you, that I think it'd be hard to do that comparison exactly without knowing where the police were deployed in the past, and they're not very forthcoming. And to be fair, I haven't asked any police departments, can you give me a detailed log of the like geotags of your police officers over the course of the year? Because I mean, that's pointless. I know that's not going to happen, and I think to do a really good job of that, that's probably what you need. But I would love for some studies like that to be done, and I would really love for there to be more sort of like academic, or maybe not even academic, but more, study of sort of policing practices in general. All right, I think we're good, huh?
Yeah, so as Kristian can see,